Hello, I wish to discuss our recent work on the impact of large H1 optical depth on the 21 centimeter from cosmic dawn. The exact equation for estimating the differential brightness temperature is given in equation 1, where we note that there is a factor of 1 minus e to the power minus tau, where tau is the H1 optical depth. Normally, this H1 optical depth is assumed to be much less than 1, and under this assumption, equation 1 is reduced to equation 2, which is widely used to model the 21 centimeter signal from epoch of ionization and cosmic dawn. Now let's look deep into this optical depth, and we see that the optical depth is proportional to the density, H1 density, and inversely proportional to the spin temperature. During cosmic dawn, spin temperature is the lowest just before the heating starts. So the optical depth can be very large just before the heating starts, particularly at regions with higher H1 density. Then that above assumption may break down. So if we use the linearized equation to interpret the observed global signal, we found out that the estimated spin temperature can be overestimated by 5% in the standard kind of scenarios and by 10% in the excess cooling scenarios. Then we try to model the 21 centimeter signal from cosmic dawn and investigate the impact of large optical depth. We consider two scenarios: one, the standard scenario, and another is excess cooling scenario, where the IGM temperature is much colder, which is consistent with AGS measurements. The right panel shows the difference in delta TV calculated using two equations, and we found out that the calculated delta TV is actually over predicted by 30% if we use the linearized equation. Particularly regions with higher densities are affected more. Then we also looked at the probability distribution function of TV and found out that if we use the exact equation, the probability distribution function becomes more Gaussian. So the non-Gaussianity is somehow reduced. Then we also looked at 1-point statistics and found out that the variance is over predicted by 30% and 90% in the standard and excess cooling scenarios respectively. We found similar numbers for the skewness and kurtosis. And then at the end, we looked at the power spectrum and found out that the power spectrum is enhanced by 25% and 80% almost at all scales for the standard and excess cooling scenarios. So we found out that it is important to use the exact equation, otherwise there will be huge impact on the various statistical quantities of the signal. For more details, I request you to look at this following paper. Thank you for your attention.